Welcome back. In the previous video, we have looked at the general principle in differentiation. We mentioned that we have the general principle, we have the first principle, we have the product rule, we have the quotient rule, and the implicit rule. So here, we want to look at the first principle. You can refer to the previous video for the general rule or general principle. So I will take one example so we can use that to explain it better. I have a question y equal to x. So let's say this is example 1. Y equal to x. And let's apply the first principle in dealing with it. And so this is going to be easy and simple. Alright? Let's get into it. What you have to do is to take y plus delta y, or change in y. So remember, differentiation is all about a change, the accelerating, the momentum that has been altered. You have a speeding car, and the car is able to cover up a number of distance within a particular time frame. And then here's the case when the road is not that smooth, so it speeds and then it slows down. And differentiation of calculus comes in to help you deal with such what solution. It helps you know how many hours you can spend to reach your destination. So we see the change in y, and this is also going to be equal to change to x plus change in x. You are also taking the same thing for the other side. Now notice this before I continue. In other books, you may see them using y plus h of x, or h is still the same thing. And this is going to be equal to f of x plus h of x. It's still the same thing, so don't worry to see that. But what the emphasis here in the first principle is the change in y and the change in x. In other words, we have y to moving to y1 over x2 moving to x1. This is a change in y and this is a change in x. It was moving in a particular velocity and has moved into a different one. So we have this as the velocity or the rate of movement or the slope in do that. So that is when it changes to. And we call this delta, right? Delta y. So without wasting time, we are looking for change in y over change in x. So we make change in y the subject. So I have delta y to be equal to x plus delta x. Then this is y. Bringing it to the other side will be minus y. Now, in our question, we already have y. Y is equal to x, so we replace it with what? Dx. So delta y is equal to x plus delta x minus dx there. Alright? So now we have x minus x cancels, leaving delta y to be equal to delta x. We are looking for delta y over delta x. Therefore, I divide here by delta x divided by delta x. So my delta y over delta x is equal to 1. This goes itself 1. And this is the answer. Now note that change in y is trying to say that the y over the x, which is still the same thing, and it's equal to that. Now remember, applying the general rule that we did, applying the general rule, we know that this is going to be equal to, this one here is 1, so 1 times x, it will be 1 minus 1. And this is equal to 1 x is equal to 0. Any number that's 1, 0 is 1, therefore we have 1. So from the general rule, you're going to know that it is, the answer is still 1. So this is using the first principle, right? Let me get next example. Example 2. So we have y to be equal to x squared. So in this particular format, you go to the same y plus delta y, or change in y, x plus change in x all squared, because we are dealing with the x there, that's what we are expanding, and it's all squared. This is y plus change in y. We've got to expand this, so I'll have x squared plus 2x delta x plus delta x squared. So from the binomial expansion, we're using the Pascal triangle. So I have 1 to 1, right? 1 to 1. In here, we can expand it this way. We know that that is not a continuation. We now have x plus delta x is a square, so it means it's multiplying by itself, like this. So x times x is x squared. X times this is delta x times that, plus delta x times x, which will give you x delta x, plus delta x times delta x will give you delta x squared. Now, don't make a mistake by saying that delta x times x is delta x squared. No, it's not the same, because this is treated as one separate variable from the x itself. So we can't combine them and say that they're the same. And so this is going to go to x squared plus x delta x plus x delta x. That will go to 2x delta x plus delta x squared. And that is where I have this one. So you can use the binomial expansion quickly and you can arrive at this place. But this is how you can also use the expansion method. Alright? So now I have y. Let me just group like terms, right? So we have delta y to be equal to x squared plus 2x delta x plus delta x squared. I'm bringing the y here is going to be minus y. And this is going to be equal to x squared plus 2x delta x plus delta x squared minus, we already know this in the equation, y is equal to x squared. So I replace the y with x squared, which is going to cancel with this. This is leaving 2x delta x plus delta x squared. Hope you're following. Now we have this. We are going to do what we call factorization, because we have delta x there and delta x there. So this is going to be delta x factorized out, leaving 2x. So when I take delta x multiplied by 2x, I'm going to get 2x delta x plus, this was delta x squared. 1 is factorized out, 11 is only 1 of it. And I have my delta y still on the other end. So I'm looking for delta y over delta x actually. So what I have to do is to divide both sides by this particular delta x. And this is going to cancel this one. Now leaving my delta y over delta x to be equal to 2x plus delta x. And this is what we are looking for, delta y over delta x. But yet, we have